All right, so now what we're going to do is we have our critical numbers, so we're going to draw our derivative number line. Now, what I encourage you to do is don't just put down 1 because 1 is not the first critical number in the number line, right? In our number line, the first critical number would be -1/9 and then our 1. All right, so then from there, what we're going to do is we're going to have our 3 intervals. So we have our first interval, our middle interval that we need to test, and then our last interval. Now, here obviously is where a lot of the work and a lot of like the tediousness comes in because we need to test 3 numbers. There is a way to do this on the graphing calculator that does make it a little easier, and I want to talk about that as one of the methods. So there's basically 3 ways you can do this. The first way is you'll see, okay, so for this first interval, maybe I decide I'm going to plug in -2. And then for the second interval from -1/9 to 1, maybe I decide to plug in 0. And then for the third interval from 1 to infinity, maybe I decide I'm going to plug in 3. All right, so one method, and I'm going to take this into 3 methods. So method 1 is that you can plug it in to the unfactored, the standard form derivative. All right, so what you would do is you would just go back up here to where you had originally taken the derivative and plug in your -2 into that function. So, or into that derivative, I should say. So it's going to be -72 times -2 squared plus 64 times -2 plus 8. And what you would do is you would plug that in on your scientific calculator or graphing calculator and get a negative. Then you would plug in your 0. And so if I plug in my 0 into the derivative, again, I go through and I compute that, and that gives me out a, so I would have a 0, 0 positive. And then I would plug in 3. All right, so that might require some work. So I plug in 3 squared plus 64 times 3 plus 8, and that gives me a negative. All right. So the purpose of those is to determine if it's increasing or decreasing. This is one way that you can do this. You can plug in directly into the derivative before you factored it. The other way that you can get these pluses and minuses is you can go, and this is like method 2, so this is another way that you can do this, is you can use the factored form. So if you use the factored form, what you would do is you would go right back up here to where you set the derivative equal to 0. So right back to where I set the derivative equal to 0. And that factored form is going to create for me 3 factors and therefore 3 columns. So the -8 is a factor, that's going to be its own separate column. The 9x plus 1 is a factor, that's its column. And then the x minus 1 is its own factor, its own column. And then just like we did over here, you would plug in -2. So for the -8, there's nothing to plug in. The 9 times -2 plus 1, and then -2 minus 1. So what you would do here is you would think about for each of these columns, what is the sign? So the first column has a negative. The second column, you would compute this. So you would say negative, or 9 times -2 to get -18 plus 1 to get a negative, and then -2 minus 1 to get a negative. And the idea here is that if you have these 2 negatives together, that will give you a positive. Then if you take the positive times a negative, that will give you a negative. So you'll notice I didn't really feel any need to touch my calculator for this. I was able to do this very easy mental math of, okay, I have a negative times a negative, therefore it's a positive, and then that positive multiplied by a negative will give us a negative. And you'll notice that's exactly what I got when I plugged it into the standard form, the not factored form. So you can also continue doing this where you would have -1/9 to 1, you would plug in 0, and again, you would look at what is the sign of those factors. So the first factor is negative. The second factor, you have 0 plus 1, so that's positive. And then the third factor, you have a negative. So what you would do is you would say I have a negative times a positive. That gives me a negative. Then that negative times the last negative will give us a positive. So you see that you do in fact get a positive. All right, and then you would do the same thing for f prime of 3. It would be very similar to the first case. So that is method 2 of how you can complete this number line. Method 3 is the graphing calculator, and I am not promoting this, but I want to just, especially if you're like really rushed for time, on your test, you must show the derivative number line. All right, there has to be some number line shown, and and this will be very clear on the test. I'll write this out, and you have to put in those signs, and you have to show that you are plugging into the derivative. Now, when it comes for how you get those numbers, you can plug into standard form, you can plug into factored form. Technically, you could also plug into your calculator. Now, this is not graph the function. This is use second table to identify the signs that you have for your derivative. So here's what you would do. You would take your calculator out, you would hit the y equals button, and then you're not graphing the function, you're looking at the derivative because that's the inequality you're trying to solve. So you plug in -72 x squared plus 64x plus 8. And then you see how we plugged in -2, 0, and 3. And for x, you would then go to second table and look at -2 gives me a negative. Then cursor down 0 gives me a positive, and then cursor down 3 gives me a negative. And that's how you could very, very quickly identify negative, positive, negative. Okay, now again, I'm not promoting that. Again, the whole idea is that we're doing this without a calculator, but technically in this class, you're allowed a graphing calculator, so you could use that second table. But everyone, graphing calculator or no graphing calculator, on your test, you must have this derivative number line because that's the whole point. The whole point is that we're learning this method of using our derivative to find the max and min.